Okay, so we are going to discuss about the median and quartiles in this video for the continuous random variable. Right, so in the previous video, we already learned some basic idea about the continuous random variable, where there are two important properties that you need to know. The first one is when you integrate the whole function, the function for the whole domain that given in the question is always equals to 1. That means the area under the graph defined is always equals to 1. Okay, and then after that, you learn the second thing is how to find the probability for a continuous random variable. So generally, you need to do the integration also lah. All right, so the probability is actually equals to the area under the graph. So the limit, you have to see what is the limit that they want. So when you integrate the limit with the function itself, generally you will get the probability after you do the integration. Okay, so this is two basic introduction, the concept that we learned in the last video. So for today, we are going to extend it to median and also the quartile. All right, so the learning outcome for today is use the probability density function to solve the problem involving probability to calculate the mean and variance. Mean and variance we will cover it in the next video, and also to get the median and so on. All right. Okay, so we will start with the median first and also the quartile. Generally, the median and quartile having the same concept. All right, so let us start now. Okay, so before I start, right, so I just want to let you know, just to recall back. So last time you learned about median and also the quartile, correct or not? So when you're having the data, okay, so generally having the data, okay, smallest value to the largest value and so on. Now, let's say I'm having all the data here, some numbers here, and I arrange it from smallest value to largest value. Okay, so where is the median actually when we learned it last time? So median is actually we are looking for the center, okay, of the whole set of data, right? So the location of the center or the middle, okay, that particular value we call as median, which means if let's say you look at the smallest value to the median, right, it covers 50%, okay, and then this is median, and after that you are having a 50% here also. All right, so that means it's the median actually try to separate the data into two parts, okay, which is the first part 50% and also the second part of 50%. All right, so the 50% here, when we want to bring it into the continuous random variable, it is something like a probability. That means what? So that means this is the smallest value. So let's say the smallest value is A. Okay, and let's say this is the smallest value, which is the largest value, which is B. So the middle value is the median. That means if let's say we try to bring this concept into the continuous random variable, generally it's like this. When you try to integrate the smallest value to the median for a particular function that you have in the probability distribution, then you will get the answer equals to 0.5. Okay, so this is the idea. 0.5 means the 50%. That means when you integrate from A until median, right, the probability or the area that you get should be half of your whole set of data. So you write it like this. Smallest value is the A. Integrate until median for the function that it gives you, it is equal to 0.5. Or the other way is you can integrate from median to the largest value. So that means you are having median to the largest value B for the function that they give you, it will also can let it equals to 0.5. So if you carry out either of these integration, right, you will be able to get the value of the median. All right, so I hope that you roughly have the idea about this. Okay, so median means it covers from the smallest value until median, right? It covers half of your data, which is equals to 0.5. Okay, so the same idea will be applied for quartiles also later. All right, so here let us continue with some notes in our notes. Right, so here they say that median of the distribution of x is defined as the value which divides the area under the graph in half. So denoting the median by m, so you can see that, okay, let's say this is my whole graph here. So you want to cover the half part of your graph, which is by 5. Okay, so they are talking about the area is 0.5. It is not saying about from A to B, the midpoint, no. Okay, don't confuse about the midpoint between A and B. Because if let's say you're having A is the smallest value, B is the largest value, median is not necessarily every time in the center. Okay, because we are talking about half of the area. We are talking about the area, we are not talking about the value on the midpoint between A and B. So you cannot tell me that, can I straight away take A and B divided by 2 or not to get a median? Cannot. Alright, so we are talking about area. Please remember this. A lot of students will actually misunderstand it. Okay, so it doesn't mean that median is always in the center. Not necessarily. So please don't confuse about this concept. Okay, alright. So if let's say you want to get a median by looking at the area equals to 0.5, which means when you try to integrate from A until M for the function, you should let it equals to half. Okay, so usually I will tell students, you try to remember this concept for the median part. So, or you can do it the other way around. That means, like what I showed you just now, you can integrate from M until B for the function fx, and you let it equals to half also can, no problem. Either one of them. Alright, so as long as you understand the concept and the idea here, generally, it is not hard for you to apply it. Okay, so not necessarily you must remember both also, like just remember one will be enough. Okay. Alright, so this one we have after the median part. Okay, so if you understand the concept, right, you can extend it to the quartiles, like the lower quartile, also the upper quartile. Okay, so for lower quartile, it means what? First quartile, so we label it as Q1. So first quartile actually cover the first 25%, okay, of your data. That means from the smallest value until first quartile, it is actually 25%. So you can write it like this. Okay, integrate from A until fx, it is equals to 1/4. Or you can do it the other way around. That means when you try to integrate from Q1 until B for the function itself, so what is the value that you should let it equals to? So if this is 0.25, right? So this value should be 0.75, so that it equals to 1. The total area under the graph equals to 1. So you can let also Q1 integrate until B, you let it equals to 0.75 also can if you want. Alright, but for me, usually I just memorize this one because it fulfills the definition that we learned all the while. Right, when you're having the smallest value until Q1, it actually covers 25% of your data. The first 25% of your data. Alright, so usually I will memorize the basic one. If let's say you want it to be, how to say, maybe sometimes you realize that when you integrate like this, maybe it is easier for you to get the answer, then you can do it like this. Alright. Okay, then for the Q3 also the same thing. Also for Q3, it covers the first 75% of your whole set of data. Okay, so that means when you want to find the Q3, right? So integrate smallest value until Q3, and you let it equals to 3/4. All right, so this is what we have lah. So to me, all the concept of median quartiles are the same. So make sure that you understand the idea about it, then generally it has no problem for you to find out what they want. Alright, so it is quite simple actually. Alright. Okay, so this is what we have for the median and also the quartile. So maybe we can start trying some questions here. Okay, so let me have a look. Okay, example 6. Okay, so maybe you can I can discuss example 6 with you, and then you need to try some other example later, right? Okay, so let's start with it. So they give you a probability density function, which is fx equals to this function, and then the domain given is x is between 0 until 1 only. So first part, they want you to show that k equals to 3. Okay, so how are you going to show that k equals to 3? So you have to apply the concept that you learned last week, or maybe in the last video, which is from 0 until 1 when you do the integration, because the whole domain is 0 until 1. Then after that, you want to integrate for x power k, and you let it equals to 1. Okay, so 4 is a constant, I just copy. When I want to integrate k, x power k, so x power k, when you do the integration, means the power plus 1, so you have k plus 1 divided by k plus 1 divided by the new power, and you need to substitute 1 and 0, it is equals to 1. Okay, k plus 1. K plus 1 is a constant, therefore I just take it out. I substitute the 1 into the x, I'm having the 1. I substitute the 0 into the x, I'll have the 0. So it is equals to 1. Alright, so I think from here you should see that k plus 1 equals to 4. Therefore, k is equals to 3. So you already shown that k equals to 3. Okay, so this concept, this property, we learned it in the previous lesson. Alright, okay, so not hard, ground up. Okay, then now let's continue to part number 2. Okay, so for part number 2, they want you to find the median of. So to find the median of x, you know that when you integrate from the smallest value until median, I assume that m is the median, right? So when you integrate from 0 until median for 4x power 3, the probability is equals to 0.5. Okay, so 4 is a constant, I just copy it out, and then I'm having x power 4 divided by the new power, and then substitute m and also 0, you let it equal 0.5. Okay, so eventually you have m power 4, which is equals to 0.5. Alright, so if you continue further, you take power 1 over 4. So when you take power 1 over 4, you get 0.841. Okay, so we only consider the positive value here. We didn't consider the negative value. When you take the root of 4, right? The fourth of root of 4, generally you need to consider plus and minus sign. But I only get the answer for the positive sign only. Why? Because you see that your x are all the value of the answer that you get should be between 0 and 1. So if your median equals to negative value, which is wrong, median should be also between 0 and 1. Alright, so I will only select the positive value, which is negative 0.841. Yeah, alright, so again, not hard, as long as you get the idea, that is quite simple actually. Alright, then let's continue to part number 3. They want to find the interquartile range of x. Okay, so to find the interquartile range, you need to get Q1 and also Q3. Right, so let's start. Q1 means when you integrate from 0 until Q1 for the function for x power 3 dx, it is equals to 0.25. So if you do the integration and substitute the value later, right, you will get you will have Q1 power 4. I try to skip a few steps here. You will get Q1 power 4 is equals to 0.25. So for Q1, I will write it as 0.25 power 1 over 4. So for me, I didn't press out the value yet because to me, this is not the final answer. So I keep it in the original pattern first. Alright, then after that, I will get Q3. So integrate from 0 until Q3 for x power 3 dx, you will have it equals to 0.75. So the same thing happen here. If you continue further, you'll get Q3 power 4 equals to 0.75, and therefore your Q3 should be equals to 0.75 power 3 over 4. Sorry, power 1 over 4, because you want to take the root of 4, right? So 1 over 4. Okay, so again, I will keep this in the original form like this because this is not the final answer also. And then when I want to get the IQR, interquartile range, so it is actually 0.75 power 1 over 4 minus 0.25 power 1 over 4. So by pressing the calculator, you should be able to get the value in 3 different figures, which is 0.223. Okay, so this is what I have for the median and also the quartile, interquartile range. Alright, so I hope that you understand the concept here and then you know how to apply. Okay, after that, continue to part number 4. Okay, so part number 4, they are talking about find the probability that exactly 4 out of 6 random observation less than the lower quartile. Okay, so again, when you look at this one, I don't know whether you realize or not, it is actually the binomial structure, because from 6 random observation, 4 of them, something happened. So this is a structure for binomial question, right? So generally, it is binomial distributed. Okay, although the original idea they're talking about continuous random variable, but if you look at this structure, it is actually a binomial question. That means I will use y lah. I'm not going to use x anymore. So y is binomial distributed. You're having 6 observation, and then they said less than the lower quartile. So what is the percentage of the data that is less than the lower quartile? Should be 0.25, right? Okay, and then what they want you to calculate is they want y equals to 4. So if you continue from here, 6C4, 0.25 power 4 and 0.75 power 2. Therefore, you will get 0.0330. Okay, I believe that when I discuss this one with you, right, when I mentioned that it is binomial distribution, then you have no problem to get an answer. But the problem now is a lot of students, they actually don't realize that this question belongs to binomial distribution. So that's the problem. Alright, so again, there's no specific keyword for you to identify the binomial distribution. So you have to really try to detect the question yourself. So the pattern I always tell students is, you're having a large number or maybe a bigger number of the observation or sample, and then a smaller number out of this large number here, like 4 out of 6, or maybe 9 out of 12. Something happens, so less than something happen means that less than the lower quartile. Alright, so there's no, to me this is a pattern. Alright, so you have to identify the pattern yourself. There's no keyword. So this is what you have for example 6. So from this question, you see that they actually try to link also the binomial distribution that you learned in the last semester with this continuous random variable. Alright, so just make sure you know how to identify it. Okay. Alright, so no problem. Let's continue to the next example. Okay, so for example 7, it is quite straightforward. Okay, so I just want you to have a try yourself on your own. For median, first part, the median answer should be 2.83. It's very simple for this one. And then for your IQR, interquartile range, you will get an answer which is 1.46. But for your information, you should get Q1. Q1 is a 2. And also Q3 is square root 12. Then after that, you can get the IQR, which is 1.46. Okay, so it is not hard at all, very simple. Okay, so continue to example 8, also the same thing. I will want you to try this out on your own. Okay, so the median for this question is 1.26. All right, so all this you can try on. It is not hard at all. Totally it is very easy. Totally not hard one. Okay, all right. So if no problem, then let's continue again to example 9. Okay, so if you try to read example 9. Okay, so they give you a function like this. Okay, and then first they said they want you to find x greater than 2. And after that, they want you to deduce the value of the upper quartile. Okay, all right, so maybe we can start now. All right, so we say that they want to get the probability for x greater than 2. That means when you do the integration, you try to integrate from 2 until 4, because the largest value given in the domain is a 4. All right, so you integrate from 2 until 4, and then for the function that they give you, 1/8, then 4 minus x dx. Okay, so again, 1/8 is a constant. I will just take it out, and then I will integrate 4 to get 4x. Integrate x to get x squared over 2. And then I try to put in the 4 and 2 here. Okay, so what do I get after I substitute the value? So if you try to substitute the value, you'll get the answer 1/4. So this is the probability. Okay, all right. Then after that, they ask you to deduce the value of the upper quartile. Okay, so to deduce the value of the upper quartile, if you want, right, you can actually try to maybe sketch the graph if you want, but actually it's very simple also, not hard. Okay, so when you're having 1/8, 4 minus x, when x equals to 0, you get 1 over 2. So maybe this is 1 over 2 when x equals to 0. Okay, then you let y equals to 0. When y equals to 0, your x is equals to 4. Okay, and then they said that the domain given is from 0 until 4. So which means your graph is a triangle like this. Okay, and then when you find out the value for x greater than 2, the probability that you get is 1 over 4. So which means 2 is here, right? So this probability is actually 1 over 4 only. So this part is 3 over 4. Okay, so you can see that when you are having a value from 2 until 4, the area covered is 1 over 4. And then from 0 until 2, the area covered is 75%. So this one is 25%. So I think you can see very clearly now. When you're having the smallest value until a certain value here, okay, and the probability is equals to 75% or 0.75, that means this particular value will be your Q3. Okay, so they just ask you to deduce. Deduce means that just look at the answer, your answer in the calculation here. You can straight away deduce that the Q3 is actually equals to 2. This is the upper quartile that we have. Okay, done. So this is how we do it, right? Okay, then after that, for part number 2, they want you to find the median of x. So again, this question itself is quite easy. If you do it correctly, you will get 2 values for the m. The first one is 6.83, and we will ignore this answer. Okay, so why do we need to ignore this answer? You have to think it yourself first. If you don't understand, come and ask me again. I won't tell you this one for now, but we actually ignore the answer for 6.83. All right, and after that, the answer that we accepted is 1.17. Okay, so this is the answer for median. 6.83 is not the correct answer. So 1.17 is the correct answer. Okay, so this is what you have for part number 2. All right, then after that, we continue to part number 3. So again, find the probability that less than 2 out of 8 observations of x have value less than the median. Okay, so again, I don't know whether you can see the pattern here or not. Less than 2 observations from a larger value, from the 8 observation, something happened to them. So something happened means less than median. Okay, so again, this is the binomial distribution. So you're having y, which is binomial distributed. You're having 8 observation. What is the probability for less than the median? So less than the median is 0.5. And they actually want you to calculate the probability for y smaller than 2. Okay, so again, the same thing happened here. Please make sure that you try this on your own to get the answer 0.0352. To me, I don't think that this is hard because once I tell you that this is a binomial distribution, generally it has no problem for you to get the answer. Okay, so this is what I have for example 9. All right, then after that, we continue to example 10. Okay, so if you continue with all the example that we tried just now, all the discussion that we tried just now, you will see that they actually give you the how to say the function itself, right? You can go through with all the example, then you will see that they give you all the function, the formula, everything. But sometimes they won't give you the function also, like example 10. So if you look at example 10, it is a partial question from year 2010. All right. So if you look at this one, they give you a figure, and then they said the value taken for this function is from 0 until 2 only. Then first, they want you to find the probability for x smaller than 1.5. Okay, so x smaller than 1.5 means that if you look at the figure, this is 1.5. Okay, and then this is the area that they want you to find. It is a triangle actually. Okay, so now the problem is how can we find out this area? So some students will say, can I just use the formula for the triangle area? Can if you want, but our problem now is actually we don't know what is this value. Okay, and then some students will tell me, eh, if let's say look at the graph, it seems like it's 0.75. Okay, but actually we cannot show that it is actually equals to 0.75. If you want to try your luck, of course you can, because some students say it is a linear function. So from here is 0.5, from to here is 1, so the middle part should be 0.75. It sounds logic actually. Okay, so you can use 0.75 multiply with 1.5 and then divide it by 2 if you want. Okay, but how about if let's say you can't really get the value from the graph, then how? Okay, so if let's say you don't want to guess the value here, what you can do now is you can actually form the equation yourself. So how to form the equation yourself, the function? So first you look at this value, this coordinate is 0, 0. And then if you look at this one, when you label it out, it should be 2, 1. The coordinate is 2, 1. Okay, so if let's say you want to form the equation, then you can find the gradient first. So what is the gradient for this straight line? Okay, so you can take y1 minus y2 divided by x1 minus x2. So you'll see that the gradient is half. And after that, I use the passing point 0, 0 and also this gradient. I try to form the equation. So y minus 0 equals to mx minus 0. So y is equals to half x. Okay, so once you know the function already, this is your function actually. Y equals to half x means that this is your fx. So to get the probability, you can start with the integration. So x smaller than 1.5 is equals to what? Integrate from 0 until 1.5 for 1 over 2x. Okay, so this is how you actually try to get the answer, okay, for the probability by finding out the equation first. Alright, so I'm having 1 over 2. Okay, I'm having 1 over 2 here. And then I'm having, I forget to write out the x. Wait, so there's an x here. Okay, so half x dx. So I'm having 1 over 2, and then integrate the x, I'm having x squared divided by 2. And then you put in the value for 1.5 and 0. Okay, so you will have generally 1.5 divided by 1 over 4. Okay, so if you continue with it, you should be able to get 0.5625. Okay, or you can change it become 0.563 if you want. Okay, so this is how we do it now. So there are 2 ways for you to do it. First one is you can try to guess the value here. Is it 0.75 by using the common sense and so on? You can do that if you want. If you don't want, then you want it to be safe, then you try to form the equation, and then after that you do the integration. Okay? Alright, so this is what you have for part number 1, which is a bit special because this question generally they didn't give you the function formula. Either you find out or maybe you just use a figure to help you if you want. Okay, and then after that, there's another important part here. We go for the second part here. So they are asking, is the upper quartile of the random variable x greater than 1.5, equal to 1.5, or less than 1.5? And then they want you to give a reason for your answer. Okay, so why is it? Okay, some students, when they look at this question, they will try to do the integration and find the value for upper quartile. Okay, but for this question, generally you no need to integrate anything again because you're having the value for x smaller than 1.5. Okay, therefore, for part number B, you can try to write the value here. Okay, I'll try to draw a number line. The smallest value that in this question is 2. And then the largest value that we have is 0 and 2, right? The largest value is 2. The smallest value is 0 for the value of x. Okay, so if you look at this probability, x smaller than 1.5, the area covered is 0.563, which means if let's say you're having 1.5 here, then this area itself is 56.3%, something like this. Okay, so now by using common sense, right, your Q3 should cover how many percent from the smallest value to Q3? Okay, so if let's say according to common sense, the Q3 should cover 75%, correct or not? 75%, which means that your Q3 should be somewhere here. Okay, because according to the percentage, you look at the percentage, 1.5 cover 56.3%. Therefore, the Q3, what you want to cover is 75%, so it should be further than the 1.5. So you can draw this number line in the exam, and you can try to tell them that Q3 is greater than 1.5. Okay, so again, if let's say you feel that it is like not so secure, then you can try to do the integration to get a Q3 first, and then you compare also can. Alright, but I believe that they won't give you the marks for the integration. Understand what I say or not? Okay, so just make sure that you, if let's say you want to save time, you can try to understand this method here. Okay, alright, so this is what we have for the median and also the quartile part. Alright, so I hope that you have the idea how to find out the median and quartile. Alright, and in the next video, in the next lesson, we are going to discuss about how to find out the mean and also the variance for a continuous random variable. Okay, then after that, we will end this chapter already. So the mean and variance will be the last part for our chapter 3. Okay, so see you in the next video then.